Hey there, so what is the quadratic formula and where did it ever come from? Stay tuned and we'll find out. So in previous videos, we learned how to complete the square to solve quadratic equations. Everybody's favorite thing to do, right? But this method shows how to do it a little bit differently using what's called the quadratic formula. So essentially, if we write a quadratic in standard form using A, B, and C to represent the coefficients of the quadratic term, the linear term, and the constant, and we complete the square, this is what results. So a lot of students may not know where this comes from. So this is the origin story of the quadratic formula. So the first thing to do when we complete a square is to get rid of this a. We want this to be a 1x squared. So in order to do that, we go ahead and we divide through by a, because we're allowed to do that. Naturally, a is not equal to 0 because in the quadratic formula over here, we're dividing by 2a, so that can't be 0. It would never be 0. So we're going to go ahead and do that. So what happens is those a's cancel out, and we're left with x squared plus ba x plus ca equals 0. So there we have it. We have the startings of it. So remember what needs to be done is this middle term needs to be cut in half and squared. So that ends up looking like b over 2a squared is what we want to have. So we're going to do that. We're going to say, all right, x squared plus b over a times x. And I'm going to kind of move this to the other side. Because what we want to do is put this, whatever this is, some people call it your secret number. So we're going to add it on both sides. So let's go ahead and do that. So when I add b squared over 4a squared. So I'm just squaring this, right? Square the top, square the bottom, we get 4a squared. So we have to add the same thing on both sides, because that's the rules of algebra. Whatever you do on one side, you must do to the other side. So there we go. So far, so good. So what we're going to go ahead and do is write this in squared form. So this would become x minus b over 2a squared. So that's what this whole thing becomes here. Right? b over 2a before we squared it. So on the right hand side, we're going to have minus c over a plus the b squared over 4a squared. So on the right hand side, we're going to try to add these together. So I have to have another factor of 4 and a factor of a. So up on the top, I'm going to add a 4 times a. So I think you're seeing where these things are coming from now. But let's keep on going. We'll keep working through this. So I will leave this in squared form for a second while I simplify the right-hand side. So I would have b squared minus 4ac all over 4a squared. So that should look kind of familiar, at least the top part of it up here, right? b squared minus 4ac ends up becoming our determinant. I should say discriminant. In any event, I'm going to go ahead. Let's take the square root on both sides. We are allowed to do that in algebra, right? So there's taking the square root of both sides. And the square root of something squared is the something. And on the right-hand side, also remember when you're taking the square root, this is where our plus or minus is coming in. So we're going to have plus or minus. Then I'll have b squared minus 4ac. And then I'm going to go ahead and take the square root of this stuff because it's a perfect square. So 4a squared has a square root of 2a. So now, when I go to solve for x, I'm going to add this term on both sides. So it's b over 2a plus or minus the square root of b squared minus 4ac all over 2a. And they have the same denominator, so we can end up combining these. So that ends up being x equals the, whoops, I just realized I'm missing a, that was a plus, that was a plus, that was a plus, making that a minus. Because I knew my formula was wrong. Looking back up here, notice a minus b. And down here, I was not noticing minus b. So that made me look back to see that I had a plus here, but I did not write the plus here. So that's how easy it is to make a mistake in your algebra. So be very careful. All right, so that becomes the opposite of b, plus or minus the square root of b squared minus 4ac all over 2a. So if you can remember this formula, you will never have to complete a square again. Hallelujah. So how does this formula then work? Let me show you just a quick example. Quick example right here. Let's go ahead and rewrite this. We'll move this linear term over to the left-hand side. So that'll be x squared plus 7x minus 9 equals 0. Just quick, are there any factors of 9 whose difference is 7? No. 9 and 1 have a difference of 8, and 3 and 3 have a difference of 0. So this does not factor, just double checking that. So let's go ahead and use our quadratic formula, which is opposite of b plus or minus square root of b squared minus 4ac all over 2a. But what is our a, what is our b, what is our c? Well, a is 1, so that's what we'll be substituting in for a. B, well, that is a 7, so that will be getting substituted in the formula where it has a b. And c, our constant, is a negative 9. So wherever I have a c, I'm going to put the negative 9. So let's go ahead and do that. So x equals the opposite of b. So b is 7, so the opposite of b of minus 7. And that'll be plus or minus the square root of b squared. So I'm just going to put all the subs in, a and c. And that's all over 2a. So just real quick, the 7, the opposite of 7 is the opposite of b. b squared is 7 squared. 4a is 1. c is negative 9. All over 2a. a is 1. So at this point in time, it's just a little bit of algebra. Just got to do some simplifying here. So sometimes good things work out when we're simplifying. Other times, not so much. So we'll see. X equals negative 7 plus or minus. Let's see, 49 and 36 is what, 85. All over 2. So this won't simplify either, this 85. 85 is 5 times 17. So neither 5 nor 17 are perfect squares. So square root of 85 is as good as it gets. So we'd have two solutions. Sometimes we just leave it like this, have my students put a box around it. Some people like to go -7 plus, just plus square root of 85 all over 2, and then they will get a decimal approximation, but you don't really have to do that. So -7 minus square root of 85 all over 2. And that is, for a lot of students, doing that with the quadratic formula over here is much easier than completing the square, which, ironically, is how we came up with the quadratic formula, is by completing the square. So the quadratic formula, there you go. The secret to the quadratic formula was completing the square. Now, you'll probably never have to complete the square again when you're solving these equations, but you will complete the square again when you start to graph quadratics towards the end of Algebra 2, especially in pre-calculus. So, in any event, hope you've gotten value from this. Go ahead and hit the like button. Share it with anybody who you think wants to view it. And until next time, this is Mark Nolde signing out.